All right, my friends. Again, it is a little silly for us to be using this formula right now because there weren't very many terms, but I'm hoping that we at least have that magical feeling of we get the same answer as when we did it the other way. So if you practice using this formula, A means the first term if you were to expand it out. And I will say for these, it's kind of a good idea to expand it out at least a little bit. You'll see in part B why I say that if if it doesn't make sense already. So now for part A though, you want to be really careful because if they had started at 1 instead of 0, then you would have had 6 terms, but they didn't start at 1, they started at 0. So you actually have 7 terms. So for part A, your n value should be 7 because when we expanded it, if you go up to that warm up, you could count them if you want, but really a way to think it out, if you don't want to expand things, is if it started at 1, goes to 6, you would have had 6, but it didn't start at 1, it started at 0, so you have an extra 1. So you'd have 7 terms. What's your first term? Your first term would have been what you got when you put 0 in, and so it would have been 5. And then you also need to be clear on what your common ratio is. And when we expanded it out, it became very clear that your common ratio was -2. So you need to, oops, I guess I should call that R. So it's important that you don't assume these 3 numbers. Some of them can be a little tricky. Like on this one, the n value could have been tricky if you weren't a little careful. Okay, now so now putting things into the formula. So the sum will equal your first term being 5 times 1 minus your common ratio is -2. Your n value, your number of terms, is 7, and then divided by 1 minus your common ratio. So now simplifying this and stick tight to the order of operations. So let's see, what on earth is -2 to the 7th power? Well, 2 to the 6th was 64. So this would end up being -128. So we'd have 5 times 1 minus -128. Is that right? 64 times 2. Yeah, 128. There we go. And it's all over 3. That's adorable. Okay, so we'd end up with 5 times, now we're adding 129 all over 3. Now, why multiply 5 times 129? Just to have to reduce it by 3 again, when we could cancel between the 3 and the 129. So 3 goes into 129 43 times, and then we just do 5 times 43, which would be 200 for the 5 times 40 and another 15. So there we go. The same thing we got when we did it term by term. There we go. Okay, so hopefully at this point you're getting a feel for this formula here. It's not my favorite. It's kind of along the lines of harder to remember and kind of harder to execute correctly, especially with something like Part B. So let's get set with Part B real quick. Part B, that if in doubt expanded out part that we did in the warm-up is pretty important for a couple reasons. One, you can tell what your first term was. So your first term was 4. I'll just write that down. Number 2, you can see what your common ratio was. A lot of folks would look at the rule in the beginning and say common ratio is 1/2, but because you had this extra 2 on it, your common ratio actually ended up being 1/4. And you can see evidence of that when we started expanding it out. You can see evidence of that like in our simplified version down here as well. So your common ratio is actually 1/4. And then the number of terms, you could see when you expanded it, you had 4 terms. But even better, remember if you had gone from 1 to 5, you would have had 5 terms, but you started at 2. So you don't have 5, you have 4. So I'm trying to show you kind of a couple different ways to figure out these values. So, okay. So when you get down here to the example we're on, you just need to make sure you keep those things clear. So your first term was 4, your common ratio was 1/4, and your number of terms was 4. There you go. Okay, so now putting everything into the formula, we would say that this sum is equal to your first term, 4 times 1 minus your common ratio to the nth power all over 1 minus your common ratio. Okay. Woo. So now let's simplify it as we go. So we'd have 1 minus 1/4 to the 4th. I know 4 squared is 16. I know 16 times 16 is 256. So we'd have 1 over 256. And then all over 1 minus a 4th is 3/4. Oh, goody. Okay. So now we'd have 4 times 1 minus 256 would be 255 over 256. And you're dividing the whole thing by 3/4, which is the same as multiplying by 4/3. There we go. Okay, I'm going to rewrite the first one as 4, sorry, the first 4 as 4 over 1, and then I'm going to cancel some stuff. So remember 256 was just 16 times 16. So I'm actually going to cancel this 16, 4 times 4 is 16 with the 256 and get 16. And then 255 is divisible by 3. I know that because if I add the digits 5, 5, and 2, I get 12, which is divisible by 3, which means it makes sense to cancel between the 3 and the 255. So 3 divided by 3 is 1, and 255 divided by 3 is 85. Okay, so my final answer would be 85 over 16. There we go. And let's compare that to what we got when we did it term by term. Boom, 85 over 16. There we go. Okay, so now you have 2 ways to do problems like that. If in doubt, expand it out, or using this formula, but being careful to make sure you have the right values for A, R, and N, in which case maybe just a little bit of if in doubt, expand it out would make that super clear for you. Okay, and that is the main goal for the lesson. So the last thing we need to do is make sure that we show how to prove that this formula is the way it is. So first thing we would do is write the word proof and then underline it. And then the proof of this one is actually going to start out with an expression for the sum of the first n terms, but like in a term by term fashion. And keep in mind that this is only for geometrics. So between now and the next video, what I'd like for you to do is, let's say the first term is A. I'd like for you to show what the second term, the third term, let's have you go ahead and show the fourth term. And then this is going to be the sum of the first n terms. So go ahead and show what like the nth term would be. So you're going to build in the second term, the third term, the fourth term, and the nth term for a just basically a generic geometric where your common ratio, your first term is called A and your common ratios are. See how it goes. Check in with me in the next video.